Let's take a look at an example of a hypothesis test from start to finish. So, a Washington Post article from 2009 reported that support for a government run healthcare plan to compete with private insurers has rebounded from its summertime lows and wins clear majority support from the public. More specifically, the article says that 7 in 10 Democrats back the plan, while almost 9 in 10 Republicans oppose it. Independents divide 52% against and 42% in favor. 6% voted other. There were 819 Democrats, 566 Republicans, and 783 independents surveyed. There's a lot of information here, and to be honest, I'm not sure what of this is important yet, so I'm going to keep reading. A political pundit on TV claims that a majority, okay, that's a buzzword, I'm writing that down because majority has a really specific stats meaning. We'll come back to that. Of independents oppose. Okay, so I'm looking at independents opposing. So 52% were against, opposed, and 42% were in favor. So for independents, our sample success rate was 52%. This means oppose. Now I need my sample, and the sample I'm looking at here is for the independents, and there were 783 independents sampled. It asked for my hypotheses, my p-value, my conclusion, and my conclusion in context. I'm going to do the 4 steps of a hypothesis test. Now I'm circling back to this phrase majority, because right now I only really have one proportion, and I can't do a hypothesis test if I just have a data but not a claim. So the claim here is majority. And majority means more than half. So the null hypothesis is going to be p equals 50%, not a majority nor a minority, just half. Alternative would be more than half. So whenever it says majority, your null is equals 50 and your alternative is greater than 50. I'm going to use this to do my 4-step process of my hypothesis test. First step, and a little redundant because I already have it, but my hypotheses. I'm going to write them down again. Null is equal to 50, alternative is greater than 50. Since it has this greater symbol, when the time comes, I'm going to have this thing shaded to the right. And I can actually already draw a rough sketch of this thing up to some amount of distance away from the center, because your claim or your middle is always coming from the null hypothesis. The spot where you start to shade is from the data, and our sample success rate for independence was 52%. And the p-value is going to be the size of that shaded in region. So you're going to have claim in the center, the data is where you start to shade, the p-value is the size of that shaded region. For the model, I'm working with proportions. They're normally distributed with the center of p, and a standard deviation of square root p cubed over n. P hat is the name of the model. I don't plug anything in there. My p is from the null hypothesis. That's 50%. If p is 50%, then q is the complement of that. 50-50, 50% success, 50% failure. And the number of samples for independence was 783. I'm going to type that into a calculator to see what I get. I've got the square root of 0.5 times 0.5 over 783. That gave me a standard deviation of 0.0179 or so. My third step is my p-value step. And the p-value is the likelihood, I'm looking at the probability of something, of my sample data. Well, my sample data was the success rate of 52%. Or more extreme, I'm using the symbol from the alternative. I'm looking at greater. If the null hypothesis is true, I want it on this model. So I'm going to calculate my test statistic, or in other words, I'm going to calculate my z-score. My z-score is my sample value, my p-hat, minus my claim for my center, my p, divided by my standard deviation, the square root of pq over n. My sample data was 52%. The claim was 50%, and my standard deviation was 0.0179. I'm going to type this into a calculator and see what I get. 0.52 minus 0.50. In your calculator, if you hit the up button, you can select previous text. And I'm going to do that just so I don't have to type in my standard deviation again. And I get a z-score of 1.12. Now I'm going to show you how to look this up both in a normal table and in GeoGebra. If you are using a normal table, you are going to go to the 1.1 row. The first two numbers give you the row in the 2 column. So I'm going to go to 1.1 meets the 2. And when I do this, I get a table value of 86.86%. Now I'm noticing in my picture that significantly less than 86% of my curve is shaded in. In fact, this is probably closer to like 13%. And that's because your table is giving you the area to the left. So to get this area to the right, to get my p-value, when it's shaded to the right, I need to do 1 minus the table. I need to look at the complement. And when I do that here, that gives me 0.1 minus 0.8686 is 13.14%. I will show you how to get this same p-value inside of GeoGebra, but let's do our conclusion while we have this p-value. Since our p-value is bigger than most reasonable alpha levels, for example, 5%, this is also called the significance level. If your p-value is large, that big or bigger, we fail to reject the null hypothesis, which means we do not have evidence of the alternative. In this case, we do not have evidence that a majority of independents oppose this national health care plan. Now, I want to show you how you can get these same results from GeoGebra. When you open it up, you can go into the option for probability. And if you're looking at normal and you leave this as 0 and 1, you could type your z-scores in here and it will spit out your p-value down there. And you can choose left, right, or two tails, depending on what your picture looks like. Our picture was shaded to the right, so I'm going to choose this option, shaded to the right. And the z-score I'm going to type in on the inside here was this 1.12. And this gives me the same p-value of 13.14%. Looks great. If you wanted to double check this whole process here, you could also go into this option for statistics. Test our hypothesis test, and estimates our confidence intervals. So we are looking at a test, not of a mean, but of a proportion. We're not looking at the difference. We're not testing two different groups like independents and Democrats. We're just doing a single group, just independents. The null hypothesis claim was 50%. And we were testing for more than that. We were testing for a majority. The sample success, I don't know how many successes I had, but I had a success rate of 52% times my 783 samples. So about 407 people for the sample supported this. For the total number of trials, I had 783. When I did this, I got a z-score of 1.12, looking great, and a p-value of 0.135. Let's go into MyOpenMath and type in our results. Testing for a majority. So I should always see the numbers match. So that's a pretty good indication that this one is wrong. They're not matching. And a majority means more than half. So I see that majority right there for my first option. It asked me for my p-value. That was 0.1314. My p-value was greater than or equal to my alpha, so I failed to reject the null hypothesis. Since our p-value is greater than or equal to alpha, we do not have enough evidence to reject the null hypothesis. So this does not provide evidence to support the pundit statement. Because we failed to reject this null hypothesis, 50% is probably a pretty reasonable value for our confidence interval. So because we failed to reject, we expect 50% to be in our interval. And I'm going to use GeoGebra here and doing that z estimate of proportion, that confidence interval, just to see. Z estimate of proportion. I'm looking at, say, a 90 or 95% confidence. And it didn't give me the level, so 95 is fine. And it gives me a lower of 48.5 and an upper of 55.5. When we are looking at type 1 and type 2 errors, we'll see that we probably actually should use a 90% confidence interval, but that doesn't matter. 50% is still between 49 and 55. We failed to reject the null hypothesis. We expect that value from our null hypothesis to be in our interval. So would you expect this to include 50%? I would say yes. So this is what I had for this hypothesis test example. I hope that helped. And when I check, green check marks all the way down, that's looking great. Hope you have a great day, and I am around for questions if you have them.